The next thing I want to do is create a similar plot, a similar SF object. Instead of using points, our objects in this case are going to be polygons. So here you might think about two counties, and we're going to shade each of these counties based on some attribute, like the birth rate or maybe the death rate or something like that, population density, whatever the case might be. So I'm going to create my geometry objects first. So just to kind of see the idea here is we create each object, then we're going to kind of merge those objects together into a list that we assign to the geometry list column. And then we're going to attach some data to that, and that's going to give us an SF object. So in this case, I've got outer one. That's going to be a matrix that has two columns and five rows. Outer two is going to be another matrix, which is going to define a separate polygon. So this is not a hole inside of a polygon, but rather we're creating polygon one. PL1 is going to be one polygon. PL2 is going to be a second polygon. Then I'm going to create a list. Each element in that list is a polygon. And then I'm going to create an SF column, a geometry list column using the st underscore sfc function. And the input into that function is my list of polygons. So let's run this code cell and check the class of this second geometry list column. And we can see, just like the prior one that we had, that is an SFC. It's a geometry list column. But now we have a second ID here, which is telling me that each object in that column list is a polygon. Then I can create an SF object. I need to attach some data. In this case, I have two polygons. So to each of these objects, I'm going to assign some value. So let's just say we have two counties and we're keeping track of how many new cases of some disease were reported in each of these two counties. Maybe there were 10 cases in county one and there were 12 cases in county two. County one is this first polygon. County two is this second polygon. So now I can merge the attributes and the geometry list column using the st underscore sf function. So now I've got a column of cases and I have a column of polygons in my SF object. And the class of this, again, we get indication that this is an SF object, which is also a data frame. So we have a data frame. Just one of the columns of our data frame is a geometry list column. That makes this also an SF object that has some additional structure to it. And now we can plot this by doing plot SF2. I don't need to indicate a variable like I did in this plot because there's only one attribute. So it's going to plot that by default. And here you can see the cases. And this used a default color palette. So we have 10 cases over here shaded in blue, and we've got 12 cases over here that were shaded in yellow. So these are two square counties, maybe that border each other and have different new cases reported, and we're going to shade those polygons based on the number of cases that were reported in that region. Okay, so let's think about what happens if we if we combine different geometry types. So here I'm going to create a geometry list column that I call GLC3. And we're going to create that by taking a list of points. So I have 3 points in my list and 2 polygons. So this is going to consist of these 3 points that we plotted earlier and these 2 polygons. So I'm going to join those 5 objects together into a list. And then I'm going to convert that list into a geometry list column with st underscore sfc. So that's what this is doing. This is going to store this new geometry list column to an object I call GLC3. So this now has 5 elements in the list. 3 of them are points, 2 of them are polygons. So let's check out what the class of that object is. And it's telling me this is an SFC. So this is the geometry list column. And we're told here that it's not a point or a polygon, but we're being told geometry. This means that this is a geometry collection of different geometry objects, some points and some polygons. But now we can create an SF object even if the objects in our geometry list column are different objects. So some of them are points, some are polygons in this case. So I define my geometry list column with GLC3, and I name that geometry. And then we go ahead and just assign some random data. So I'm just going to pick 5 values at random and assign one of those values to each of these objects. And that is going to be stored into an SF object I call SF3. And so now I can see the class of this. Again, it's a data frame, but one of the columns is special. It's this geometry list column that has some additional structure, so we can see it's also an SF object. And now we can plot it, and I'm just going to indicate what symbol to use for the points. This is going to be a closed tot. And now I added this argument PAL, which is which color palette do you want to use to shade the values. So here I'm going to use the topo colors palette. And here is the output that is created. And what is a little bit difficult to see here is we have 5 objects. So the first one was this point at 0, 0. The next one was this point at 0, 1. It's hard to read this point, but if you look closely, there's a yellow point right over here, which is point 3. And then we have polygon 1 and polygon 2. And they've all been shaded based on the value that was randomly assigned to each of these objects. So if you have a different random seed, if you didn't set the seed, you might have different colors in the output that you generated because these values are being randomly assigned. I did set my seed in the very first code cell of this notebook so that every time I run this code cell, the same numbers are randomly generated, so I'll get the same values assigned to each of these objects. But one thing to point out is that the actual breaks that are used for these color gradients over here, they don't have equal width, which could be a little misleading. So these colors are being assigned based on different ranges of values that have different widths. So that might be something we want to override, and we can override that with defining our own breaks. So what I've done here is I've said, what is the minimum value in that attribute column? What is the maximum value? And here, the topo colors, I'm going to use 12 of them. So I could choose how many breaks I want to use, but this is going to determine how many colors I have. So if I have 12 breaks, that should give me 11 different colors in my palette. So let's run this code cell. And the only difference between the output here and the previous one, we have slightly different colors that were assigned because now we've assigned more breaks. So we have more kind of gradient to pick from over here, and we've chosen them to be equidistant. So here's the first color, the second color, the third, the fourth, the fifth, the sixth, 7, 8, 9, 10, 11. We have 11 colors that we define these breaks so that each of these ranges of values has the same width. And that's a good attribute to have in your plot. Otherwise, it might be a little bit misleading. Okay, so that is how we could plot a couple of different, how we can create and plot a couple of different SF objects. We had one that were points, we had one that were polygons, and then this most recent one had a geometry list column that had both points and polygons in it. And so I'll just say that if you have different geometry objects that you want to include in a plot like this, rather than join them all into a single SF object like we did, a better game plan is typically to create a plot for one type of object and then create a second plot for the other type of object. So for example, here, I could create one SF object for the points and plot that. Then I could create a second SF object for the polygons. And when I plot that second SF object, I can add an argument to it, which is called add equals true. I can set the add argument equals to true. And what that's going to do, it's going to add that plot on top of the previous plot. So I would get essentially the same result in the end. The workflow is a little bit different, but it's getting beyond the scope of our kind of initial dive into SF objects. So I'm not going to kind of use that argument in this case. Okay, so that is a wrap on creating these SF objects and plotting them. In the next video, we're going to talk about how we can import shape files as SF objects and then work with some actual like counties and things like that rather than just constructing our own arbitrary objects.